Now, in this video, we want to write as a single radical. So I'm going to give you some expressions. I'm going to rewrite these guys to be just one radical. So for example, we're going to take this guy. We're going to take the square root of x times the fifth root of x. These guys have a different index. They have different indices. So I need to combine these guys, but I can't do that right now as it stands. The first thing I need to do is to rewrite this using exponents, because like we saw in the last example, if I rewrite using exponents, there's a lot more stuff that I can do with that. Okay? So how can I rewrite the square root of x?
X to the 1/2 power.
This is x to the 1/2 power, because this is understood to have an index of 2. And what about the fifth root of x? How do you write that?
1/5.
You write that as x to the 1/5. Do you all agree?
Mm-hmm.
This first step is this section. The next step is not. These guys have the same base, so what do you do with exponents? You're going to add them. So that means I have x to the 1/2 plus 1/5. Please make sure that you write this correctly. We are not adding the x's. We're adding their exponents. That's the property that we had just seen here. Whoops. Right here, when I multiply, I add the exponents. This is a property that we've already done. Right? So, I've got to add these fractions.
Is it x to the 7/10?
Are you asking or are you saying?
Asking. Is it x to the 7?
It is x to the 7/10. You get a common denominator and you add those. How do you get a common denominator? We just had a whole chapter working with fractions, with nasty polynomials where you had to factor. These guys are not nasty. You know how to add fractions. If you don't, you get help. So how do I go from x to the 7/10 back to a radical? Make that conversion back.
The 10th root of x to the 7th.
That is the 10th root of x to the 7th. Do you agree?
Mr. Craig, if you don't put the, like, if the 7 isn't under the radical sign, it's going to be wrong, right?
For this writing as a single radical, this is how I want it to be written. I mean, this is the same thing as saying the 10th root, whoops, the 10th root of x to the 7th. That's the same thing, but it just looks neater to write it this way. So that's how we want to write it.
Okay.
Now let's do another one of these guys. That way I can put this on a test for you. Question? If I take the 4th root of x to the 3rd divided by the cube root of x squared, I'm going to work this guy very much like I did the last problem. So what's the first thing that I need to do?
Change them to exponents?
Turn them into exponents. So how do I convert these guys back into exponential form?
X to the 3/4 power
I'm going to have x to the 3/4 divided by what?
divided by x to the 2/3 power.
Now, what was the rule for division with exponents? What do you do when we're dividing? We subtract the exponents. Now, understand that when you subtract, it's always the top minus the bottom. So for this guy, he's going to be the 3/4 power minus 2/3. Okay? So what do you get? You get 1 over 12. So x to the 1/12, or 1, yeah, to the 1/12 power. And then how do you convert from this guy back to the radical? Remember, the denominator is your exponent.
12th root of x.
The 12th root of x, what happened to the numerator here? Where does that 1 go?
Understood to be there?
It's understood to be here. I don't need to write that. And so then I've got this guy and I'm done. So in both of these examples, it's about first converting to exponents, and then you use exponential properties to finish simplifying this. Because when I go from here to here is this section. When I divide, that means I subtract exponents. That's working with exponents. This is working with fractions, but then coming back here to a single expression, that is working in this chapter, in this section.